Today we're talking about rational and irrational numbers. A rational number can be written as a fraction while an irrational number cannot. So the decimal form can be either terminating or repeating. What do I mean by that? Well, if we look at these, all whole numbers are rational. These are positives and zeros. All integers are rational. The reason why this circle is around this one as well means that integers are also whole numbers, because these right here, whole numbers are also integers. These right here are whole numbers and they're integers, while these negative opposites are just integers. These are all rational numbers. What about numbers that aren't integers and aren't whole? These are also rational numbers. For example, a negative fraction, decimals, negative decimals. I should have had this one in there too, so write that one down. Okay, these are all rational numbers. Irrational numbers cannot be written as a fraction, and these numbers go on and on forever without having any repeats, okay? Now, there could be a pattern, but it can't repeat. Okay, what do I mean by that? For example, pi is irrational. 3.1415926, that goes on and on forever in no repeating form. 89 as a square root is 9.4339813, and nothing is repeating. Even if I had something like this, 0.1, 0.11, 0.111, are these repeating? No, this is irrational, okay? What then is the difference? These cannot be written in fraction form. So when we look at ordering numbers, sometimes we need to first make sure that they are rational versus irrational. So let's look at these four for me. Sorry, I skipped to the other slide. This is a -7/8, the square root of 5, 25/100, and 1/9. Okay, there's two right off the bat that you should be like, yeah, those are rational. And it's this one because it can be written as a fraction, and this one because it can be written as a fraction. Okay? If we look at these, then the square root of 5 is irrational because it cannot be written as a fraction. A number times another number equaling 5 gives me an irrational number. However, 25/100 can be written as a fraction. See, 25/100 equals 25/100 or 1/4. So this terminates, it ends, this is a terminating decimal. This one also terminates, 7/8. If I divide 7 by 8, I get 0.875 or 875 thousandths. So this one is equal to -875 thousandths. While 1/9 is going to go on and on forever. That's supposed to be a 1 there, and it's going to repeat. Okay, so now we need to order these from least to greatest. So we have all of these as decimals. Now we need to find the square root of 5, which is 2 and 2, 3, 6, 0, 6, 7. Do you see why it's irrational? Nothing is happening here that forms a pattern. Okay, so now let's order them from least to greatest. If we're looking at the negatives, I only see the 7/8. So he is going to fall between 0 and -1, and he's going to be closer to -1. So this right here is -7/8. Okay, if I'm looking at 25/100, that is less than a half, which is a little bit more than a fourth, which is exactly 1/4, so it would fall about right here. The 1/9 is 1 repeating, so I'm going to put an arrow right here. It's going to be in between the 0 and the 25/100. That's my 1/9. And then my square root of 5 is a little bit more than 2. So right here, square root of 5. Okay, so now let's write them ordering. Negative 7/8 is less than 1/9, which is less than 25/100, which is less than the square root of 5. So this is my answer. All right, your turn. Go ahead and try these, and I'll be back in just a second to show you what I did. So make sure that you plot these on the number line. This is supposed to be a decimal, I apologize. And go ahead, try to plot them on the number line. If you want to, label them A, B, C, D, E, and F. That way you don't have to write those numbers on the number line. Then order them from least to greatest using their original form. I'll be back in just a second to show you what I did. Okay, so the square root of 12. This is going to be negative 3 and 4, 6, 4, 1, 0, 1. Okay, and it's going on and on forever. The square root of 16 is 4. If I take 5 and I divide it by 6, I get 3 and 83 with the 3 repeating. 2/3 is a 6 repeating. I've got this as a decimal and I've got this one as a decimal. So which ones are irrational? A is irrational and E is irrational because even though there's a pattern here, the 34 repeats, the 34 repeats, and then all of a sudden it doesn't repeat anymore. It goes to 43 and then 44. So this is irrational. The rest are all rational because this one terminates, this one repeats, and this one terminates. So take a look at where they fall on number line. Okay, so A falls in between -3 and -4, but it's not quite a half. B is exactly 4. C falls in between 3 and 4, but closer to 4 because it's more than a half. 2/3, or D, is just a little bit more than a half. E is just a little bit less than a half. And F at -4.5, oops, wrong spot, Petruska, should be right here because it falls in between 4 and 5. And that is the order. So now let's arrange them in their original form. -4 and 5/10 is the least. Then the negative square root of 12. Then my decimal that was not repeating, correct? That was irrational, so E. Then we've got 2/3 followed by 3 and 5/6, and then finally the square root of 16. And that's all I have for you today. See you next time.